combined gas law. And so the combined gas law, mathematical equation, okay, you have to really know how to use it. You don't need to memorize it because it's located on our reference table T. So when you take a look at reference table T, you will see that P1 times V1 divided by T1 equals P2 times V2 divided by T2. So it's referred to as the combined gas law because it combines Boyle's law with Charles's law and Gay-Lussac's law. So if you take a look at this, Boyle's law was looking at the relationship of pressure and volume, and in his law, P and V were multiplied. So we can see Boyle's law in the combined gas law. Charles's law looked at the relationship between volume and temperature, and in his equation, volume and temperature were divided. And so we can still see it's V over T, just like in Charles's. So we can also see Charles's law in the combined gas law. So P, as you know, represents pressure, and for us, more than likely it'll be in kPAs or ATM. V is the volume. The common ones we'll see for our class is liters, milliliters, centimeters cubed. Temperature, it can only be in Kelvin, not Celsius. So take a look. Make sure all your temperatures are in Kelvin. Now, a lot of times we measure temperature in Celsius because that's the thermometer. So if we measure Celsius, before we make the calculation, we have to convert it to Kelvin. So quick reminder, the Kelvin temperature is equal to whatever we measure on the Celsius temperature plus 273, okay? Take a look. If you're supplied data, make sure that if you're given both volumes, make sure they're in the same unit. Make sure they're both liters or they're both milliliters. And if you are given both pressure values, make sure they're in the same unit, that both are kilopascals or both are atmospheres. Okay? Now here is a big one. If one variable remains the same, leave it out of the equation. So if it tells you that temperature remains constant, leave T1 and T2 out because they remain the same. Same thing if volume remains constant, just leave it out of the equation. Okay, so let's take a look at two examples here. So here we go. We have a gas that occupies 22.4 liters at STP. So STP, that is our table A, and that gives us T1 and P1. So when we go to table A, T1 has to be in Kelvin, so our only choice is 273 kelvins. When we go to table A for standard pressure, we see both values for atmospheres and kilopascals. So I like to take a look through the equation, and I notice that we're given another pressure and it's ATM, so I want to use standard pressure in atmospheres, which happens to be 1. So I know my V1, I know my T1 from table A, and I know my P1 from table A. And as I keep reading, it says what volume, so that must be the other volume, V2 is my unknown, will the gas occupy if the temperature changes to 425 K. So I recognize there's my second temperature, and changes to 1.3 ATM, so there's my second pressure. So V2 is going to be my unknown. So remember, our equation is P1 times V1 divided by T1 equals P2 times V2 over T2. So for P1, I'm going to put in the 1 atmosphere. Do a good correct numerical setup, which means its value and unit. So P1, 1 ATM, times V1, which is the 22.4 liters, divided by the T1, which is standard temperature, so that's 273 kelvins, equals, okay, P2, which happens to be, or given to us as 1.3 atmospheres, times V2, which we're solving for, divided by T2, which is given to us as 425 kelvins. Now here's the thing. We have two fractions that are set equal to each other. So this requires cross multiplication. We want V2 to stay right here, so we need to cross the other values with V2 to the other side of the equal sign. So since 425 is in the denominator, when we cross it over, it becomes part of the numerator. And that pressure of 1.3 atmospheres, because it's in the numerator on the right-hand side, it gets crossed over to the denominator. So to calculate V2, in my calculator, what I'm going to multiply together, I'm going to multiply 1 atm times 22.4 times 425. Hit my equal button, and then I'm going to divide by 273 and then divide by 1.3. If you put this into the calculator correctly, you will end up with an answer of 26.8 liters. Okay, so let's take a look at the next question. So it says a gas occupies 125 liters. So I see that we have a liters, so I'm given a volume 1. That volume is associated with 298 Kelvin, so I know a temperature, and they're throwing at us 760 mmHgs, and that's another unit for pressure. So I have a volume, a temperature, and pressure that all belong together, so I'm going to call those my one side. So I have 760 mmHg times 125 liters divided by 298 kelvins. Now I have to figure out what I'm solving for. It says, what will be the temperature? So what is big indicator that I need to solve for my other temperature? So T2 is my unknown. So here is my T2. That's my unknown. You could put X there. Temperature of the gas, if it occupies 100 liters, so I have a second volume, and that's associated with mmHg, so I have a second pressure. So I have 700 mmHgs, millimeters of mercury, times a second volume of 100 liters. So here we go. So once again, we have two fractions set equal to each other, and we have an unknown. So we need to do some cross multiplication. So we want T2 to be by itself, so we're going to cross it up and put it over up here. But at the same time, we want these guys, we have to cross them down so they swap places with T2. So now we have T2 over 298 equals 700 times 100 divided by 760 and 125. So we've got to do one more crossing over because we want T2 by itself. So the 298 has to be crossed up to the numerator. So in my calculator, I put 298 times 700 times 100. So in my calculator, it's 298 times 700 times 100. That product is now being divided by the information that was crossed down into the numerator, divided by 760 and 125. So when I solve for T2, if I put it into my calculator correctly, I end up with a new temperature of around 213.9 kelvins. If you're having trouble solving these problems on your calculator, please come and ask for help. Now you try the you do problems and show your correct numerical setups down below.